Hi everyone, I want to do a quick tutorial, I guess, on what we're going to be doing a lot with labs and matching equations to the curve fit that Excel is going to give us. So the equation we have for the Freefall lab, x final equals x initial plus v initial t plus 1/2 at squared. And now for dropping something, the initial velocity goes to 0 because we're just dropping it, so we're not throwing it. And in Tracker, I asked you to change the coordinate system so that x initial was also 0. So that means our equation simplifies down to x equals 1/2 at squared. Now in Excel, you are doing a curve fit because this is a parabola, and Excel's going to give you something like this: y equals negative 5.2 x squared plus something x plus something. So there's some numbers there too, and I don't remember what they should be. So what I'm asking you to do for lab is to literally match up the equation with our theoretical equation. So in Excel, what were we graphing on the y-axis? Well, if you look at your graph, that's position. So that's our position. So our equation looks like this. What were we graphing on the x-axis? Time. All right, so when we replace the kind of blank variables x and y with the true variables that we are really graphing, then the equation comes to this, and then if you still have that something x plus something. Whoops, not x anymore. Instead of x, what are we graphing on the x-axis? We are graphing time. So something t plus something. All right, so now I'm having you compare this equation to this equation. So x final equals 1/2 at squared. Literally just match it up. Okay, position is equal to position. Time squared is equal to time squared. What does that mean for this? It means that negative 5.2 is equal to 1/2 acceleration. From that, all we have to do to get acceleration is multiply this by 2, minus 10.4. And so the acceleration of your freely falling object, which should be about the acceleration due to gravity, should end up being that. You take that first number that Excel gives you and double it, because to get a alone, we're just going to put times 2 on both sides, and that should give you something close to negative 9.8. So if you're doing things right, that means that the number in here in Excel should be around negative 4.9. If you're getting something that's really off, what I recommend is making sure your calibration is good, because usually if this is really strangely off, it's the calibration issue. And if you are getting something like 490, negative 490, you're probably in centimeters. That's okay, you can leave it in centimeters, because 4.9 meters per second squared is the same as 490 centimeters per second squared. Just make sure your units on your data table and your units on your graph show centimeters instead of meters, and that your answer when you put your results together shows centimeters per second squared. And so the answer that you would get if you're in centimeters would be something around 980 centimeters per second squared. Perfectly acceptable. Okay, there's just a real quick tutorial on how to do it. This is more complex than normally we're going to be working with. So normally we're just going to be doing linear fits, much easier than a parabolic fit. And to give you a hint on that last follow-up question, compare this equation like we just did to the original equation and see if you can figure out how this and this match up and what those two numbers mean in the physical world. Okay, good job.